Hello everyone, let's look at problem 300. It is longest increasing subsequence. Let me read the problem description to make sure we understand it. Given an integer array nums, return the length of the longest strictly increasing subsequence. Subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Alright, so let's look at the example 1. We have 10, 9, 2, 5, 3, 7, 101, 18. Okay, so the longest increasing, we could take, say, we have 10, 9, 2. Might as well take 2. So if we take 2, and then 5, we could take 3, 7, 101. So this is 4. The longest increase subsequence is 2, 3, 7, 101. Correct. Let's look at example 2. We are given 0, 1, 0, 3, 2, 3. Now we could take 0. Then we could take 1. And now we could take 3. Actually, we could just take 2 there. So that we could take 3. So the answer is 4. Example 3, we have a lot of 7. I think there are 7, 7, 3, 4, 5, 6, 7. In this case, we just take one of them because it has to be strictly increasing. So we just take 1, 7. Alright, I think I understand the problem here. I would like to clarify a few things. Number 1 is the length of the sums. So we are given that the length of sum is between 1 to 2000 and 500. So I think this is all that we need. I don't think there is anything else to clarify, and we have all the necessary information here. But we will see as we move along the questions. Now I would like to explore some possible approaches for this problem. So early on, here, when I go through the example, I see that if there is a lower value that we encounter, but it could still be increasing, then we just take that value instead of the previous one that we have found. So I think what we can do, if I look back in example 1, if we take 10, then and then we see 9, we might as well take 9. So the length is the same, but the starting point is lowered so that in the future uh, we could take something that is strictly more than 9 instead of more than 10, so that we have more chance of getting a longer increasing subsequence. So let me write down some observation there. Um, it might be helpful or maybe not, but let me just write it down. So if prep is larger than curve, then we take the kernel. So here we see that 10, 9, 2. Then we just take 2. And then the second one we could take 5. And then we see 3, so we just take 3. Then we see 7, we take 7. We see 101, but we also see 18. So let's just say we take 18 at that time. Yeah. So that was 2. The longest increase subsequence is 2, 3, 7, and 18. Second example, when we take 0, we see 1, so we just take 0, or we could take 1. And then we see another 0 that it doesn't increase our longest increase subsequence because we have seen 0, it doesn't have much. And then we see 3, we could take 3. And then we see 2, now we drop the 3, we take 2. And then we see 3, so we take 3. Third example, we see 7, so we take it. So I think what we can do here is that if we see a lower value but it's still increasing, then we may want to consider that value. Now the problem is when we consider that current value, it may shorten our solution. So I think in this case, I just think of a test case that I think is a good one. So let's say we have 1, and then we have let's say 5, 6, and then we see 2 there. 2, 3, and then 4. So the longest increase of sequence is 1, 2, 3, 4 here instead of 1, 5, 6. But in the beginning, we would find that 1, 5, 6 is the best solution. So how do I know that I need to drop 6 and 5 and then take 2, 3, 4 and then take the 2 instead? So I think what we can do is that when we see 1, 5, 6 and then we see 2, we need to find a way to know that the possibility is that we take 1, 2. But how do we ensure that? Hmm. So we take 1, 5, 6, 2, 3, 4. Then we basically need to find a way to tell that the longest increasing subsequence that is smaller than 2 that ends with a value that is smaller than 2 is currently just of length 1, which is just 1 itself. So how can I tell that? Okay, so how about given the current solution, which is 156, we try to use a binary search on it so that we know that we could take 1 and then combine with 2. Actually, 1, 2. How about we take hmm, so if we take 1, 5, 6, we need to branch out at 1, 2, 3. So how do we know that we need to branch out? And when we see that 1, 5, 6, how do we know that 6 will not branch out? It's because the previous value is smaller than that. So when we see 1, 5, 6 is increasing, hmm, It's a bit more complicated than I expect actually. So let's see. Anything tell that the previous value there is just a 1 there. There is just a value that is less than 2. So the question is, what is the longest increasing subsequence so far that is less than 2? So that would be 1. Okay, so I think that's the thing that I need to check quickly. Yeah, what is the question means? What is the LIS that ends with a number that is less than the current one? Okay, so I think what we can do is that hmm, if I use an array, so let's say LIS of 2, I need to tell that the answer is 1. So how am I going to do that? Okay, how about this? I think I need to clarify a few more things. Clarify um, 2 is range of what is the num sub I, the range of num sub I value. It's given by minus 10 to the power 4 to 10 to the power 4. So what I'm thinking is that we create an array LIS size of 10 to the power 4 times 2. And then this way, we will use it to store the LIS. So when we look at example 1, have 10, 9, 2, 5, 3, 7, 101, 18. Then we start say first of all when we see 10, we will mark order LIS of 11 onwards as 1. Sorry, that will take like a O(n) times m complexity, which is too slow. How about we use a binary search to find one? I mean, to find the value that is less than what we are looking for. Yeah, I think that can work. So let's say we store LIS of 10 equals 1, the LSS of 9. We see that 10 is 1 and there is nothing less than 9. So LIS of 9 is 1. Then LIS of 2 is also 1. And then 5. The LIS of less than 5 is 1, so 5 is 2. 3 is also 2. Okay, I think got it. Um, yeah, basically, we just look for what is the previous LIS that we could add on to it. So 10 would be 1, 9 is 1, 2 is 1, 5 is 2, 3 is 2, 7 is 3, 101 is 4, 18 is 4. The answer is 4. Question 2, we have 0, 1, 0, 3, 2, 3. So here we could do, say 0 is 1, 1 is 2, 0 is 1, 3 is 2, 2, we see 1, so 2, 3, then it is 3. Sorry, 2, we see that that is 1, so the answer is 3. 3 is 2, so 2 is 4. Okay, now question 3, we see that that is all 7. So it all just becomes 1. Yes, I think this could work. Um, so what we're gonna do is that we store a key of what we have seen so far. Then if we keep on adding stuff until, so we need to create a list. So how do I tell, for example, in example 1, how do I tell that the number before 5 that I've seen so far is 2? Do I know that? Okay, so I think I need to use a heap here so that I can insert item and then I can search for an item that is less than the current one. Then the insert and searching would take the slogan. I think that can work. Alright, I think what I would need now is I need to check the API for heap. So let me do it very quickly. Python heap queue. Heap queue.heap push. Alright, so I think this sound reasonable. Does it sound reasonable to you? I am pretty good about this. Yeah, proceed to coding. Unless you would like me to explore further optimization. Okay, so let's look back at example 1. Okay, I think I just go straight into coding. So first of all, I'm gonna call it let's just call it scene. Create array. Now I'm gonna look through all of the numbers, but while doing so, I need to check the previous one. So we need to look into the list. So initialize scene as an empty list. Then I'm gonna look through the nums. Other than the list of scene, I also need a dictionary. Just gonna call it lis. Okay. So now in nums, I'm gonna try to find out the number that is less than the current number. So I'm gonna do let's just call it search. And then gonna start into prep equals search of nums. Then if prep then heap queue, actually prep then lis of num equals lis of num. So lis of prep plus 1. Else lis of num equals 1. And then gonna heap push it. Heap push the current number. Don't forget to check the solution. The solution, I'm gonna initialize it to 1. or I could set it to 0 for now. Solution equal max of solution or the current LIS. Oh no. Okay, now I need to implement the search function. Define search. So the search should be a parameter of scene and then 0 of length of scene. So scene less than right. Okay. Now I'm gonna have a mid, which is the middle part of left and right. So left plus right minus L over 2 if sin of M is less than, need to pass in target. If sin of M is less than none, then I try to search it on the right hand side. So return sin M plus 1. What if there is no one on the right hand side? Then we need to return none, right? Okay, how about this? Let's just do it in the beginning. I'm gonna check if left is larger than right, then I return none. So that in the iteration, I'm gonna check the return equals search for scene and plus 1 right target. Then if not returned, I'm gonna return the current value. Then else, if the scene is larger, then I need to search on the left. Left minus 1 target. Right, okay. They got it. Right, now let me quickly go through the code again to make sure I don't miss anything. First of all, I have a scene list that I use as a heap, and I will have the lis to keep the longest increasing subsequence that ends with the key. The solution is just my way of storing the maximum lis so far. So far. So first of all, I'm gonna look through all the tops. Then I will add in I will search for the previous value before the current num. If I found it, then I'm gonna increase the lis of the current number from the previous number. Lis of the current number. Otherwise, I set the current lis as 1. Then I push it into the heap. Okay. So for the search function, I'm gonna call the need value. Alright, first of all, I will check if the left and right makes sense. If not, then there is no point, so I just return none. Then within the function, I'm gonna try to search for the maximum number that I have seen before the current number. So that would be if there is no larger number, then I just return the current one, which is fine. Okay, so I think this will work. Let me test the code real quick to make sure it works as expected. So example 1, when we have 10, so 10, 9, 2, 5, 3, 7, 101, 18. Then the lis is here. Then the scene has 10, lis is 1, and then scene becomes 9, 10. Lis becomes 1, then 2, 9, 10. So on and so forth. So I think it worked as expected. Let me quickly put the code into LeetCode to make sure it runs alright. So same service. Then forget to import queue. Then I will have lis is dictionary, and then the solution, which is currently 0. to do that, just take the max at the end. So now for num in nums prep equals search sin 0 length of sin and the number. So here if 12, then I'm gonna update the list of num equal list of 12 plus 1 else list of num 51. Actually, because it is a dictionary, but I'll just do it later. It's not important for now. Then here I'm gonna put it into heap queue because the scene. I import the num into the scene. Okay, I got everything. Now let me define the search function. Scene left, right, and then tag. Actually, the num. Mid value would be left plus right minus L divided by 2 is scene of M dot get a less left rather than the right one, then we return none. So scene of M is less than none, then not list of 12 equals to search. So let's just call it prep equals, if not the prep, search scene left right is minus 1. Sorry, this would be n plus 1 right, and then no. Okay, if that is the case, we're gonna return scene of M. Otherwise, gonna return the scene is search on the left side. Search scene left command minus 1 and none. Okay. In the end, we just need to return Can I use assignment expression? Expression. If not proof, then this has to be in bracket. Okay. Search text 3. Text from 2 to 3 for certain argument 3 was given. Okay, so search has to be, I think we cannot do it this way. How about we move it inside the line of this function to make it private? So, if scene list is out of reach, how is it possible? Because the length is 0. Okay. So how do I avoid this problem then? So if I take 2 to 3, because the length is 0, so it's not valid. Okay, how about this? Left is equals to right. Actually, I think what I should do is call it with the length of scene minus 1. Next, list key. So output is 2, expected is 4, which I got the wrong answer. If scene.m is less than, if the make is less than, then I try to maximize it further. Actually, that's not the right approach, right? What we want is maximize what we have seen so far. We want to increase the length. So let me just print the list here. List 10, 9, 1, 1, 2, 1, 5, 2, 3, 2. 7 is 1. Y is 7.1. Something is wrong. The logic is seen M is less than. Then we try to maximize it. Okay, I think I got a task that will fail my logic here. So I'm gonna put it in 5. So let's say we have 0, 5, 1, 2, 7. So the answer is 0, 1, 2, 7. But in my logic, it will try to add it to 0, 5, 7. Yeah. So that's not right. Okay, so I think I'm doing it the wrong way here. Because what I need to store in the heap is the length. See? So if I store the length, say length 1, the maximum is 0. Minimum is 10. Then I becomes 9. And then I becomes 2. Then 5. Now I'm looking for 2. And then 3. I will look for 2 as well. I think this is like a greedy approach, is it? If I take 7, then I see there is 5 there. Or even I could take 3. think I need to rethink my approach here. So 7 is 3. So I need to get the 5. I find the 3. Alright, I think I need to pop it. So it's better that way, is it? Okay, so I think I need to test my logic before I code it. So in here, what we would have is 10. There we have 9. There we have 2. And there we have 2, 5. Then we have 2, 3. Then we have 2, 3, 7. Then 1, 1. And then we have 18. So let's look at example 5 then. 0, 5, 1, 2, 7. So S1. Then the sin we have 0. Then we have 0, 5, 2. Then we have 0, 1. 0, 1, 2, 3. 0, 1, 2, 7, 4. Now it's sample 2. We have 0, 1, 0, 3, 2, 3. So when I add sin, 1, 2, sin 0. We have 0, 1, and 0 again. We don't care about that. Step 1. Then 3 is 3. So what if it cuts the queue?